Hey everyone, it's that Math Magician. On this video, we're going to continue to look at our final review for our geometry class. We are almost there for our spring final, and we are working through this PDF full of lots of questions for concepts that might pop up on that final. So let's look at problem number 9. It says, number 8, I can't read. Pythagoras High School has a math building in the shape of a regular polygon. I'm sure that that's going to be important for us. We have a math building in the shape of a regular polygon. Remember, regular means equal sides and equal interior angles. Okay, it says when Mrs. Woods measured an interior angle of the polygon, which was inside her classroom, she got 165 degrees. A says, how many sides does the math building have? Show how you got your answer. So this is a very interesting question. We have a regular polygon for our building. We know one interior angle is 165 degrees. We want to know how many sides there are. Well, we know all the interior angles are the same in this building, which then means that all of the exterior angles are going to be the same as well. Remember, interior and exterior angles, they are all going to be equal in a regular polygon. Well, if 165 degrees is my interior angle, then my exterior angle is going to have to be 15 degrees. I know that my exterior angle is 15 degrees because interior and exterior, they have to add to 180 degrees. Okay, so if I know one of them is 165, 180 minus 165 gives us 15 degrees. Now the reason why I'm switching over to exterior angles is because I know for any polygon, no matter how many sides, regardless if it's even regular, I know that the angles are always going to add up to 360 degrees. And since I know that every exterior angle on the outside of this building is 15 degrees, well, I can take 360, divide it by 15 degrees, and if I do that, 360 divided by 15 degrees, I learned that there are actually 24 sides to this math building. That is our answer for question A. There are 24 sides to this math building using the exterior angles. Alrighty, let's go to letter B now. Letter B says if Mrs. Wood's ceiling is 10 feet high and the length of one side of the building is 25 feet, we'll find the volume of West High School's math building. West High School, I thought it was Pythagoras High School. Looks like it switched names midway through the problem. It's all good. So we want to find the volume of this building now, knowing that the height is 10 feet high and the length of one of the sides is going to be 25 feet. Now we have a 24 gone here. We can't just find, remember, volume is area of the base times the height. I know that the height is 10 feet. I got to get the area of the base shape. That base shape is a 24 gon. We don't have a magic formula for a 24 gon. So in order to find this area, we have to think back to how we did it. We're actually going to need to break it up into congruent triangles, find the area of one triangle, and then times it by 24, because there are 24 of those triangles in our 24 gon. Now, we have a method to doing this, right? The area of a triangle is easy. I need to know the base. And look, I know that the base is 25 feet. They told us that the side of the building is 25 feet. I'm going to need to know the height. And unfortunately, I don't know the height just yet. But I think I can get that because I can also find this angle here at the top. That's a central angle there in the center of the circle that's going to be formed in that 24 gon. I know all those angles are going to have to add up to 360. And if there are 24 of them, well, then I know that that angle there is 15 degrees. Now, here's the point of the problem where we're going to chop it. So we're just looking at the right triangle. Just that right triangle now. And if I'm looking at just that right triangle, I have my right angle there. This angle ends up becoming 7.5 degrees because it was cut in half. And then let's see, let me get my colors back over here. I still don't know the height, but my base is also going to be chopped in half as well. But looking at that problem there, this looks like a tangent problem. I can use tangent very quickly to help me find the height of that triangle. Tangent of my angle, 7.5 degrees, is going to equal opposite over adjacent. Put the left side over 1. Let's cross multiply and solve this out very quickly. H times tan of 7.5 equals 12.5. Right? That's just by cross multiplying. I got to divide both sides by tangent of 7.5. Tangent of 7.5. Those are going to cancel. So my height is just going to equal 12.5 divided by tangent of 7.5. Well, let's get our calculator out for that. 12.5 divided by tangent of 7.5. That gives us a height of 94.94, I'd say 7. 94.947. Perfect. There we go. Awesome. That's our height. So now that I know my height, we can go back to our original triangle here, that triangle right there, and we can find the area for that triangle, because now I know, I'll do this right off here to the side. I know that the base is 25 feet. I know that the height is 94.947. To find the area of a triangle, we multiply those two, we times it or divide it by 2. So let's get our calculator out and plug that in. I'll actually just pull the answer from that. Times it by 25, divide by 2, and I get 1186. Lots of numbers here. I'm about to circle back. 0.93 or 83.837. So that's the area of one triangle, but I want the area of the whole 24 gon. So to get that, we need to take that number and we need to times it by 24. So let's take that guy. There are 24 of those triangles in our 24 gon. That's a big number for our area. 28,484 point, let's get 3 numbers, 0.078 inches. Was it inches? No, it was feet. Feet squared. Ay. Look at that. That is the area. Whoops, my head's in the way. That is the area of our 24 gon. Now, you might be thinking, oh, we have to be done. Man, we're not even done yet, because that's just the area of the 24 gon on the bottom. We want the volume. Well, the volume says to take that area, 28,484.078, and we just got to times it by the height, which is 10. Oh, we can do this with a calculator or without a calculator. 284,840.78 feet cubed. That right there is our final volume for this high school. This is really a question about, can you find the volume of a regular polygon prism, right? We had a 24 gon on the bottom, 10 of them are stacked up. Can we find it? And we got to remember how to break down polygons into triangles. Okay, this is our method every single time. Get the base, get the height, get the area of one triangle, find the area of the whole shape. If this was too confusing and I went too fast, I have lots of videos where I slow it down to find the area of a regular polygon. Go check them out so you can make sure you pass this final. You did a good job though. It's That Math Magician, and I'll see you on the next video.